Alrighty. So we're going to go through these, and hopefully I'm just going to use black this whole time because I tried to do colors before and it just was a big old mess. So I know, let's see, we're going to have to try our best to read. It says sequences are functions. If we can determine a pattern, we can write a formula for it. See if you can determine the patterns below. So 11, 13, 15, 17. What is the common difference, or is there one? Okay, Samson?
There's common differences too.
Yeah, so if you notice each number is increasing by 2. The other thing we can note is what's the first term in the sequence, and that would be 11. Okay? Next one we have 5, 15, 45, 35. What's the pattern going on in that particular one? Charlie? So this one is multiplying by 3. And again, we could recognize the first term is 5. Okay, so right now we're just looking for patterns. How about the next one? This one we talked about in class, right, Trevor?
It's added to the previous numbers.
So
1 plus 0 is 1, 1 plus 0 is 2. So
this one is, it's weird.
It's literally like behind it. So.
Right. It's really hard to write this one out in words, right? Because it's not just the same number over and over again, but there is a pattern into how we come up with those numbers. So let's see. I'm trying to think of what they said. You add the two previous numbers. So if I add 0 and 1, I get 1. If I add 1 and 1, I get 2. If I add 1 and 2, I get 3. If I add 2 and 3, I get 5. If I add 3 and 5, I get 8, and so on. So it's kind of a weird pattern. It's a pattern, but it's definitely not arithmetic. So it says, we have some vocab here. Term. In a sequence, a term refers to each number in the sequence. For example, in the sequence 11, 13, 15, 17, the first term is 11, and the fourth term is 17. Notation. We can refer to the first term as a sub 1. This is known as subscript notation. We can also refer to the first term as f at 1. So going back to chapter 1 in functions, this is known as function notation. So fill in the chart to identify the terms using both types of notation. So you've got term, the first term is 11, and we could say that this is a sub 1. We would also say it's the function at 1. So what I'm going to do is pause this and fill it out. You guys can continue filling it out as well. So notice that the second term, 13, is known as a sub 2 or f at 2, so the value of the function f at 2. The third term, 15, is a sub 3 or f at 3. The term 4, 17, is a sub 4 or the value of the function f at 4. So what do you think is supposed to happen next? What do you think that they're asking us to do? Kenna? Yeah, they just want us to continue the pattern with the numbers. So the next number would be 19, and then we'd have 21. And then we would continue with the fifth term and the sixth term. So a sub 5, f at 5, a sub 6, f at 6. Okay? So what do you think that a sub n refers to? What do you think that means? And we talked about this, I think, yesterday. I got the same people. Haley.
Like the numbers in the sequence, like that's not the first one.
It's not the first one, that's true. But we kind of talked about it. It's kind of a silly name to call it, but Arnav?
Like the number in like the term in the sequence, you have to find like the first
Could be the mystery number, or we could simply call it this. The nth term. It's some term that they will say, hey, we want to find the 150th term, so that a sub n would be the 150th term. So we'd have a sub 150. All right, then we have some more vocabulary. It says arithmetic sequence, a sequence whose terms change by blank the same number each time. What word should we put in that blank? What word's going to make that make sense? What are we doing with that D value to get to the next numbers in an arithmetic sequence? Oh, I got the same 3 people who want to give me an answer. Matthew. Yeah. Now, somebody said, well, it could be adding or subtracting, and we just need to say adding because I can change a subtraction problem to an adding problem, right? It'd just be adding a negative. So we're going to write adding in this blank. And then it says the common difference is the number that is added to produce each term in an arithmetic sequence. So if I take the second term and subtract the first term from it, that's going to give me my D value. And that's the way that we're always going to do the subtraction. It's the second one, take away the first one. The third one, take away the second one, and so on. So what is the common difference in our sequence? So this is the one that we've been looking at, the 11, 13, 15, 17. Oh, everybody should be able to answer this question for me. Emily? It's 2. So if we take the second term and we subtract the first term, we're going to get a positive 2. Now, I put that there because signs do have a role to play. Now, if I just wrote 2, it would mean positive. Now, looking at these 6 formulas, it says which formulas could produce our sequence. So looking at those 6, there's 2 of them that tell me all the information I need to know about our sequence 11, 13, 15, 17, and so on. So which 2 are going to work? Faith, which one?
The top 2.
Say again?
The top 2.
Yeah, if you notice, a sub n equals 11 plus 2 times the quantity n minus 1. Now, they put the d value in front of the parentheses, n minus 1. We did the d value after. Is that okay?
Yeah.
Yeah, the multiplication property of, or the commutative property of multiplication says you can change the order of what you multiply, it's still going to give you the same thing. So this first one, a sub n equals 11 plus 2 times the quantity n minus 1, meets it. And then if you look over to the right at top, the only thing that changes is instead of having the a, they have the f and sub n. Everything else is the same. So these 2 would take care of everything. So then they say, okay, well, how do we figure out the 100th term of our sequence? Well, they gave us our formula. And we're going to figure out for the 100th term. So that's going to be a sub 100 equals 11 plus 2. And every time I see n, 100 goes in its place. Okay? So that's going to give me a sub 100 equals 11 plus 2 times 99, which is going to be, I'm going to write it up here. A sub 100 is going to be 11 plus 198, and then a sub 100 is going to equal, let's see, we get a 9, a 0, 209. So we would say the 100th term, actually I'm going to write it above, I know that this gets blocked off. The 100th term is 209. Or 209 is the 100th term. Okay? All right. Now, thankfully, you can read what you're writing, right? Because you're looking right at it. I know the writing from the pink page is hard to read, but hopefully you guys are all seeing everything that I've added. Are you all ready to go on to the next page? Yep. Ava, you good? Okay. So here's the next page, and it says, try to find the common difference of the sequences below to see if they are arithmetic sequences. So we've... Sit down. We're not done with notes. So what do you think the D value is in 2, 4, 6, or 2, 4, 8, 16? How do we get from one term to the next? Oh, I always have the same people. Come on. Other people should be able to see a pattern. Keenan?
Multiply by 2.
Yeah, this one at first looked like it was going to be an adding pattern. 2 plus 2 is 4, and then I did 4 plus 2 is not 8. So then you had to back up and think about, well, if it's increasing, then it's got to be multiplication. But does that make it arithmetic? No. Okay. What about the number 2? What is the D value for this one? Nathan?
Plus 10.
Yeah, you're adding 10 each time. Is that arithmetic? Yeah. And then we have -3, -5, -7, and -9. What's the D in this one? Let's see. Hudson.
-2.
We're going to subtract 2 each time or add -2. Is that arithmetic? Yes, it is. Okay, so for the arithmetic sequences, can you determine a formula? And our answer is, why, yes, we can. So let's do it. So I'm going to do it over here in the white space. So for number 2, we need one key player is the D value. The second key player is the first term in the sequence. So we start with the formula, A sub n equals A sub 1 plus the quantity n minus 1 times D. And then we just substitute in values. So we have 20 here, plus, and then I don't know what n is, so we just leave it that, and then times 10. So we're going to simplify this equation down, so we distribute, and we get 10n minus 10. And then we have some like terms we're going to combine. Put the one with the variable first, so that's the 10n, and then we have plus 10. So that's what number 2's equation would be. Let's see if I can... I'm trying to see if I can squish it in over here. Well, actually, you know what? I'm going to do it. Yeah, we'll just squish it in. So this one, we've got the D is subtracting 2, and the A sub 1 is -3. So we're going to have A sub n is equal to the first term, -3, plus the sum, or plus the quantity n minus 1 times the D, which is -2. So A sub n is going to be -3, and then I'm going to distribute, and I'm going to get -2n plus 2. I'm going to combine up like terms, and I get A sub n equals the n term first, -2n, and then minus 1. So our formula is the one we wrote down in our notes yesterday. Any term in the sequence is going to be equal to the first term plus the number of terms in the sequence, that goes up to the biggest guy, minus 1 times the difference between each term. All right, next grouping, we've got 5 sequences that are arithmetic. They tell us that, and we have 5 formulas we could use to figure out any term, and we got to figure out how to match them. So, 2 key things we should look for. What are they? Charlie. A sub 1, that's going to be easy on all of these, right? In fact, what's A sub 1 on the first one?
6.
And the second one?
0.
And the third one?
5.
And the fourth one? And the last one? -5. What else do we need to find? Samson?
Common difference.
Need to find that common difference. So what's the common difference for the number 4? Yeah, just increasing by 1. How about the next one? We're decreasing by 5. Okay, so -5. How about the third one? Adding 1 or subtracting 1? We're adding 1. Notice your numbers are actually getting larger because they're getting closer to 0. How about on number 7? Adding 6. Put a plus there. And then how about the last one? We're going to subtract 6. Okay. Now, with that information, it's going to be easy to go ahead and connect up matches. So what matches with a first term of 6 and a difference of 1? What goes with 4? Anybody? Say it out loud. B. B as in boy. So this and this. Okay, what about first term of 0 and a common difference of -5? Which one would that be? D. Okay, and what about 6, let's see, we have a first term of -5 and a common difference of +1. Which one is that? E. And then on number 7, we have the first term is 1 and the common difference is +6. That's going to be your A. And then number 8, process of elimination, it has a common, or a first term of -5, and it has a common difference of -6. Oops, sorry, I did that wrong. Let's try that again. So this guy goes with C, okay? Now, they want us to find two terms for each of these, the 10th term and the 23rd term. So this one's going to be a little messy, so I'm going to do this off to the side as well. So let's do number 9 here, and let's see what we've got. We want the 10th term, so we're going to find f at 10 is equal to 8 plus 2 times the quantity 10 minus 1. And then we're just going to keep solving it until we get an answer. So we're going to get 8 plus 2 times 9. That's going to give me 8 plus 18. And that gives me the 10th term is going to be equal to 26. Same function, this time we're going to find the 23rd one. So I'm going to draw a little line here. And that's going to be 8 plus 2 times 23 minus 1. So f at 23 is going to equal to 8 plus 2 times 22, which is going to give me 8 plus 44 for a grand total of 52. So those are the 10th term and 23rd term respectively. Okay, and then let's go ahead and do 10 underneath. I'm going to do a different color. So number 10, we've got the 10th term, and we've got -2 minus 10 times 10 minus 1, the quantity of. And then that's going to give us the 10th term is equal to -2 minus 10 times 9, which is going to give us the 10th term is -2 minus 90. So the 10th term is going to be equal to -92. Let's find the 23rd term. Oops, sorry. A sub 23 is going to be equal to -2 minus 10 times the quantity 23 minus 1. So we're going to get the 23rd term. A sub 23 equals -2 minus 10 times 22. That gives me A sub 23 is equal to -2 minus 220. Signs are the same, so I'm going to add, and the 23rd term is going to be -222. And then let's do number 11. So we're going to figure out the 10th term. It's going to be equal to 9 plus 3 times the quantity 10 minus 1. So we have f at 10 is going to equal 9 plus 3 times 9. Keep solving, and we get 9 plus 27. And we get the 10th term, and this function is going to be 36. Call me out if I do anything wrong, guys. 23rd term. 9 plus 3 times the quantity 23 minus 1. Gives me the function at 23 is equal to 9 plus 3 times 22. Gives me the function at 23 is equal to 9 plus 66. And the function at 23 is going to give me 5. Okay. So back to the last two, it says, what type of graph do arithmetic sequences produce? We're going to graph numbers 4 and 5, but you should already know that answer, right? What kind of graphs are we going to get? Say again? Linear, right? Because we have a constant rate of change. That's what that D value is. So the first one is simple. They gave us all the values, so we just needed to put them in the right spot. So 1, 6, 2, 7, 3, 8, and 4, 9. So definitely linear. And then on the next one, it wants us to go back to number 5, which is this guy here. and we're going to come up with all the values. So we're going to figure out what we get when we put 1 into this equation. And that's going to give us 6 plus 0 is 6. So we put that in here. Then we're going to put in 2. 6 plus 2 minus 1. So we're going to get 6 plus 1. I think I've done something wrong here. Am I looking at the right one?
Once you use the numbers, remember.
Oh, duh.
Yeah.
Okay, yeah, let's try that again. I was thinking, these numbers aren't matching what I remember them being. Let's try that again, shall we? So we're going to plug in 5 into this. So our 5th term, or nope, sorry. My brain's not happy with me right now. Let's see. So we're going to plug in 0 into this equation, and we get, am I in the right one? I'm sorry, I'm having a hard time here. Oh, I'm not, I know what I'm doing wrong. I got it. It's this guy right here. It's this one. That's why I keep going wrong. So when I have f at 0, I get negative 5 times n, 0 minus 1. Or, yeah.
Are we doing?
No.
I don't think zero's on it. I don't think. Because it's 1.
Okay, why is my brain not functioning today? Oh, duh. You know what? I'm so sorry. I'm just being stupid. Let's try this again. Okay, I know what I'm doing now. The first term was 0, right? Duh. The second term was negative 5. I knew I'd eventually pick it up. And we have negative 10. Then we have negative 15. And those are the ones we're going to graph. So we've got 1 goes with 0. 2 goes with negative 5. 3 goes with negative 10. And 4 goes with negative 15. Ooh, my goodness. So that also is linear. So that's what we're going to get. We're going to get lines for our graphs because these are linear graphs. These are linear functions. And that's it. Sorry about the brain freeze.